and thanks for joining us today. My name is Amy Clements, and I'll be your host for today's webinar. Our topic today is Simplify MCAD Integration with Wire Harness Design. And given the number of participants and the numbers that are still joining us right now, I can tell you that this is certainly a popular topic and it's of great interest. We have an exceptional team of subject matter experts here with us today, and I know you're going to enjoy this webinar. Before we meet our presenters, there are a couple of housekeeping items I want to go ahead and cover with you. First of all, we encourage you to ask questions. You can submit your questions in the question window and we'll answer them either during the presentation or during the Q&A at the end of the webinar. And if for some reason we do not get to your specific question, we will address all of the questions afterwards. Also, during the webinar, we're going to ask 3 polling questions, and we'll share the results with you on screen so you can see how others are responding. It's important that we hear your responses, so we really appreciate your participation in that. Today, we're joined by Cody Cobb and Saima Ahmad, both from Zukin. Cody is a program manager for our E3 series product, helping customers optimize their design processes. And Saima is an applications engineer for E3 series, and is also working closely with our customers to address their design challenges. Welcome to you both, Cody and Saima. Thanks for being here today. So we'll go ahead and get started, and I'll hand this over to Cody.
All right, thank you very much, Amy. So we get to our next slide here. So again, my name is Cody Cobb. So we'll be going through some of the current challenges today, and then I'll give you a brief introduction to our E3 3D transformer. And then Simon will be going through a short brief demo of the tool, and then again we'll leave some time at the end for some questions. So before we get started, I'm going to jump into a quick poll question.
Okay, you should see the poll on your screen. If you'll take just a moment to answer the question, what is your current role? And if you don't see your current role on there, just make a note in the comment section for us, please. Cody, do you have any predictions on what we're going to see?
I'm expecting number 3 to be our high point for today.
Okay. All right, just a couple seconds. We're going to close this poll out. And there you go. Cody, you were right. Majority of our attendees today are electrical and mechanical designers.
Perfect. We got the right crowd in for today then.
All right, there you go.
All right, thank you very much. So what do we want to talk about today is some of our current challenges of linking between our schematics and the MCAD design, and how do we fix that and what is needed, and then ultimately getting to our end goal of a manufactured harness. And so this is some of the challenges we have today. And so I'd like to go into the next slide here of just showing a quick process flow of what we have today. And so E3 3D routing bridge and E3 harness flattener, these tools have been staples in collaborating between our schematic engineers and the MCAD engineers. And furthermore, on the what's required on the MCAD side is these additional tools or licenses, or these interfaces for CATIA, Creo, NX are some of the examples. So traditionally, we have this process of a bidirectional XML interface, and this is with the E3 3D routing bridge, and that brings in length and component information. And then we kind of bring that same XML data using these interfaces to get to our ultimate goal of flattening our manufacturable harness. And another challenge that we have today is with SolidWorks and Solid Edge, that flattening capability does not exist. We only have capabilities of gaining that length information. So in this world of these wide variety of tools, and a lot of customers, they have multiple MCAD tools. And so customers have found that the needed data that they need for this extraction or define the usable formats can sometimes create iterative processes or even sometimes lost data. And in most cases, issues are found later down in the design process, and this can kind of set your teams back week or months even in that implementation phase or implementation phase. So with that being said, we're going to jump into one more poll question, just kind of get some ideas.
Okay, great. Question is, what are your top challenges? So again, if you take just a moment, select your answer, and then we'll show you what they are. I'll show you the responses. Do you have any predictions on this one for us, Cody?
No, I think this one's going to be pretty widespread. That's a tough one. I think everybody's kind of got their own issues, and I think this will fit a lot of those. So
we definitely have a clear winner here. All right, we'll close out the poll right now. And you can see definitely time-consuming processes. Certainly,
oh wow, okay,
one of the biggest challenges.
right.
Yeah.
Alrighty, sounds good. All right, thanks for the poll question there and responses. So just to reiterate, in today's challenges, we have these interfaces of Creo, NX, SolidWorks. And so having said that, what we're going to be reviewing today is this next generation solution, which is the E3 3D Transformer. And this offers a single tool that supports these wide variety of file formats, and it acts as that missing link between your schematics and your MCAD engineer. And what makes this tool even more impressive is capabilities of finding those inconsistencies in your design and allowing you to correct them within the tool. And I think this is going to greatly show some improvement in that time or process time or that we're seeing in the poll. So just to talk a little bit more about the traditional process flow. So again, traditionally, this is a bi-directional using our E3 3D routing bridge for schematics and MCAD. This is all XML information linked going into MCAD components going to MCAD and linked coming back into your schematics. So this flow isn't going to be shown today. But what I want to show is the improved process flow and how E3 3D Transformer fits into that process. So traditionally, we had these interfaces and all that data had to be extracted or converted to get the information out of MCAD to take that XML data through that flattening process. But now with this E3 3D Transformer, we have the capabilities of bringing that information directly from MCAD, no extraction process, no conversion process. You bring it straight from your MCAD tool. And then once we have that information in the E3 3D Transformer, you have that capabilities of extracting it with this tool, and we'll talk here a little bit later, that process is going to be much faster. And you would export an XML information, and you would follow through that same flattening process, and again, ultimately getting to our end goal of a manufacturable 2D print harness. So let's go into a little bit more details in this new approach in linking your MCAD and schematic engineer. Again, this is going to enhance that team collaboration, and it's all in one common tool. So again, it supports these well-known MCAD formats: CATIA, product files, JT files, XML, ASM, etc. And so where you're going to see the improved design process with this is you can quickly go from a 3D data to a flattened 2D print. And this is all because of the load and extraction time is very short and very quick. And the capabilities of healing that function, healing the information or the data within the tool also helps improve that design process time. So every engineer or company has these certain different approaches to design or design specifications when creating these 3D models. And therefore it's kind of difficult to kind of have a general approach for that extraction process. So and able to react to that and have this wide variety, accept these wide variety of requirements when obtaining that information from your original 3D models, E3 3D Transformer allows to have customer-specific profiles, config files. And so in this image, you can see you can assign Boolean expressions to take an attribute from your MCAD, for example, this ECAD type, and this is going to be labeled as a connector. So this is a plugin that within the tool that allows you to ultimately have very consistency between your MCAD and your schematics. So that way your part numbers and everything matches up, and this just allows you to accept a wide variety of different attributes between your MCAD tool and your schematics, and ultimately ending up at the right part number or right component. So this graphic illustrates kind of the standard work process or data flow of E3 3D Transformer. So here we have our inputs. So we have a wide variety of inputs from different MCAD tools. And once we import that information in, we get this window here on the left. And this is going to copy over any of the structure that you have within your file. So it's going to be exactly the same. You can turn off and on just if you're looking at a JT viewer of some sort. And then what's nice about this tool is you have also the capabilities of bringing multiple harnesses in, and that's what this topology configuration means. So instead of like previous plugins, instead of only being able to extract one harness at a time, this gives you capabilities of to do multiple harnesses and grab all files of a harness per machine per se. And so you can get a view of that 3D world of what the harness looks like in the machine, and then you can run extraction process for all of those at the same time. And this again is kind of just showing how this is going to greatly improve that process time. And during that extraction process, we talked about this customer specific profiles. So this is going to run through that plugin and essentially label these components are connectors. And once that extraction process is complete, you'll have this window here, and you'll have a list of your connectors, your grommets, fixings, etc., or segments, etc., splices. And now we have this extracted data. We're ready to run through the design for consistency checks. And this will allow you to check for any broken segments, parallel segments, etc. And we'll see a little bit of this in the demo. And then once the design's been healed and there's no errors, you can extract this information, the last step, the exporting the data or format that you need. So some of these are VEC, KBL, E3 series XML base file. One of them that doesn't show here is HCV, which is a container format. And this works well with our E3 harness analyzer as well. So I want to walk you through kind of a process scenario and kind of comparison versus other plugin tools. So I'm going to use, for this example, I'm going to use CATIA. So CATIA has this separate interface that they use to extract that data to get the XML to run through this flattening process. And that extraction time averages about 30 to 45 minutes. And this really depends on the size of your harness. And then once you have that XML data that we've seen before, you can take it through this flattening process, and that is about a 5 to 7 minute process. Now, what happens when you have errors in this extraction process? And some of these examples of errors you might see is some component mapping issues, some missing components, segment breaks, overlapping splices, etc. So when you do get an error, what this causes is you have to go back to your MCAD engineer to make any design error fixes, and then you can re-extract that process. So you can kind of see how this is a loop. It kind of creates a loop of editing that data. And so if everything's not fixed on that first loop, you're rerunning that extraction process, and this time can add up very quickly. So to give you some design flow benefits of E3 3D Transformer, within the same format, the same files, you have an average time of 2 to 3 minutes to import those files. That extraction process takes 2 to 3 minutes to get that exact same data that you would get out as the other plugins. And then running through that flattening process, again, is the 5 to 7 minutes. Now, the same question is, what if we have errors within E3, that extraction process? So what makes E3 3D Transformer outperform these other MCAD plugins is there's no need to send back to the MCAD engineer for repair. There's no need to re-extract the model again. You have these design checks within the tool, and you can fix those on the spot within that same tool. And here you can see an example of a splice or a node that is not joined or broken segment. So you can join this within the tool and fix that data. And so now you can start to see how E3 3D Transformer is going to help us get to that ultimate goal of a manufacturer harness print a lot faster, 75% faster. So I think that's enough of talking about the tool. I mean, we all want to see the tool. So I'll go through a quick demo overview of what you'll see in the demo, and then I'll jump over to Simon, allow her to walk through that. So here we talked a little bit is our traditional flow of getting that data back between schematics and MCAD. So we're going to take this JT file. Once the MCAD part is designed, you have a complete design and ready to be flattened. You can take that JT file, import it into E3 Transformer. You run your extraction process, and then you do some design checks. And then lastly, we export that information via XML, and then we run through that flattening process. And again, getting to that ultimate goal of a manufacturable harness print. So with that being said, I will go ahead and give Sima control, and she can walk you guys through a demo.
Thank you so much, Cody. All right, so the purpose of this demo is to show how E3 3D Transformer can help create a foam board drawing for manufacturing. So here is an example of the foam board drawing in E3. And if we have a wiring diagram here that is used to build a 3D model. So all this wiring diagram information would be exported to create a 3D model. And in this case, Siemens NX is used. So I am going to delete my foam board drawing just to see how we can recreate this foam board drawing. All right, so so now we open our E3 3D Transformer, and I am going to open up a JT file that was exported from Siemens NX. All right, so now the model is loading, and we see here's the model, and on the left-hand side are all the fixings and grommets and connections and everything. Okay, so now we go to extract the topology structure, and this is the main feature for this E3 transformer. We can select everything we want to come in, all the connectors and fixings, splices, etc. And we also have a couple other options of simplifying the topology structure or simplifying the segment curve. So we click OK after all of our selections. And this is the main feature of this E3 3D transformer, that it is now extracting the electrical representation of the harness. So all the segments, connector vertices, fixing grommets are coming in, and it's collecting this and putting this into a comprehensive harness topology. And it's in the E3 3D transformer memory. We also have some other settings that Cody talked about earlier. And this is the customer profile. And the customer profile is a customer specific data set that we can import and put it here. And we also have object identifier configuration that Cody also showed earlier, which is the configuration for the data set. Also, we have a property mapping configuration, which is also an XML file which defines all the attributes that are needed. Just wanted to show you that. And we also have some other settings here on the right-hand side. Loading the exact geometry from the source, loading the PMI, auto zoom, auto pan, and the white 3D visualization background. We can switch it to white or the normal 3D E3 3D transformer background. So now all this model is extracted and we see all this information on the right-hand side. So it's segregated with all the connectors. It segregates all the connectors and splices, if there are any, and fixings, and the segments, vertices, everything is segregated like that. So now we see on the left-hand side, it is everything that is bolded. It means that everything now has come in. This is not bolded, so we can try this as protection. Sorry, a fixing. So now this is taking grommets and it's putting that in the E3 transformer memory. All right, and then we also have few other checks: harness coherency checks, parallel segments checks, and segment termination checks. So we are, for the test purposes, we want to see, we want to delete this connector. and see on the left-hand side that this is not bolded anymore, which means it's not come in. And if I run a segment termination check, which means that the segments are terminated properly, it would give me an error because it would be missing a connector there. So if I run this check, it says that this check has failed. It has found one termination error. And if I go back and extract this as a connector, and now we will see that it would be bolded and it will be extracted on the right-hand side. And then we would rerun all the checks again. Okay, so now that is done, we run harness coherencies check, which checks for any gaps in the in our 3D model. It found no incoherent harnesses. Parallel segments check, it found no parallel segments, and segment terminations. So that error has been fixed. So now that we have everything fixed, we can export this data out. So for that, we go to the Exchange tab, and here are the export option, VEC, KBL, or HCV. In this case, we are going to export that as an E3 XML file. We select this, and I'm going to save this on the desktop. So here that is done. And then we have our process of flattening this. So we open our flattener, and I will open up this file that we just saved. And I am going to run this to make it flat and save this back. And now we are going to import this back into our E3 series with the help of Routing Bridge. So I'm going to do an harness import and open up the file that we just flattened out on my desktop. And I'm going to import that. So now we're going to see that it is creating this file. So here we have this file that has been created. And we can also see that all the length information have come in also. If we select this into connection property, we see that the manufacturing length from the 3D model has come in. So in conclusion, we can see that we were able to heal the data, do all the necessary checks, and extract all the information for the foam board drawing. So with that, I'll give this back to Cody.
Alrighty, so thank you very much, Saima. So if we can jump into our last poll question.
Okay, our final poll question then is, what would have the biggest impact on your process today? If you'll take a moment to review those answers and then just send us your selection. And we can see that definitely the majority of this audience would like to see that direct link between MCAD and their electrical tools.
Wow.
No surprise there.
Right, right, very true. All right, well, thank you very much, Amy. So we will continue on to our next slide here. So again, we're just going to reiterate the current challenges, and as we saw in the poll, getting the link between your schematics and MCAD design is a very big challenge for us. And then, like we talked about earlier, is ultimately getting to this manufactured harness. An E3 3D transformer, in my mind, I believe, puts a big check mark on this for us, and as we've seen that today. And there's a few takeaways that we like to talk about, and the reasonings why we think this is a big check mark on that process. One, it's a light and user-friendly application. And the second one, that having those capabilities of healing that functionality within the tool is going to greatly increase that process time and having not have to go back to the MCAD engineer to make any design changes and continuing that loop that we discussed. And the last part here is this wide variety of these file formats. And so some of these that are, like we talked about, is CATIA, NX, SolidWorks, Autodesk, Inventor, et cetera. These are just a long list of formats that are Creo or are accepted into this tool. So I think this is one big takeaway to take. This is the missing link between the two schematics and MCAD Engineer. So that's the last part that I have. I think we can leave some time at the end, like we talked about, for some questions.
Absolutely. We do have some questions from our audience, quite a few as a matter of fact, and I would encourage you to continue to type in those questions and we'll get to as many as we can. The first one I have is from Michael, and he's asking, how complete does the 3D harness need to be? For example, do we need to have the wiring fully placed in the model?
I can take that question. So it depends on the MCAD. For example, CATIA or NX, the model does not have to be electrified. I hope that answers your question. It doesn't have to be exact. It's going to take what information you do have, and you can export that out. I hope that answers your question. So for example, like CATIA, you don't need the complete wiring information. As long as you have components, bundles, or anything like that, that will be transfer over.
Great, thank you. We have another one from Micah, who's asking, why are the green segments in the demo shorter than the purple paths provided initially?
Yeah, I can talk to that one too. So that is part of the segment. I can't remember the naming or exact wording for it, but basically you take a percentage. So the original file was what showed up in purple, and then the green is that extraction information. So we're ultimately getting to a flattened harness. So the visualization doesn't really matter. So it takes a lot of times in MCAD design, there's a lot of vertices or nodes per se in the design. So it kind of makes that a little bit more efficient. So when you're going through that flattening process, there's not really long load times. And as you saw in Simon's example, it loaded pretty quickly within that E3 harness flattener. So if you have a lot of nodes and vertices within the design, it takes that simplification and makes it a little bit easier to process through. It does no length information or anything is affected. It's just really a visualization.
Great, thanks, Cody. We have another one from Jesus, and he's asking, can you import E3 data into 3D Transformer?
Yeah, you can. So you can take a XML BOM information from E3 and you can import that into E3 3D Transformer. And what that'll allow you to do is do a BOM comparison. So once you have an extracted data, you can import the E3 information in, and you will get a little check marks on that right of the extraction process or the extraction window. And you can do a compare and make sure that it's aligning up with what you have in your schematic BOM. So that's the only information that you can import from E3. Ultimately, this is going to be taking that MCAD data and extracting that information, but there are some capabilities. Yeah.
Okay, we have another from Paul, and he's asking, I saw in the demo a cross highlight with CATIA in settings. What is that for?
Correct. So yes, what you saw for this particular version, you do have capabilities of cross highlighting, and what that means is if you bring in a CATIA model within the E3 3D Transformer and you have your CATIA opened up in the background, anything that you select in E3 3D Transformer will highlight in CATIA. So there's this this cross highlight connection between the two tools.
Great, thank you. Here's another from Eric, and he's asking, how do I verify that the form board drawing matches the schematic page that I started with? Will the form board drawing created from the transformer tool be parametric with the schematic page?
That's a good question. So the answer to your question, yes. And so when you take that schematic data and you run through the process of E3 3D routing bridge and getting that data into MCAD and routing it and getting at the model where you're bringing it into E3 3D Transformer, and then ultimately going to the form board, that data should match what the form board data is going to match exactly what you have in your schematics, and that's where the specific profiles and config files come into play. Is they're going to make that very consistent. So if you have certain attributes on your MCAD side that are, connector names, or it may be named different, or there's different attributes, and when you tie that to the MCAD data. And so what those config files do is it allows you to catch the part numbers or that you use in your schematics, and that's what it'll be exported out into that XML. So that when coming in, it will match what you have in schematic. And if it doesn't, and once you have a good profile built based on your attributes, as you saw in the demo, on the left-hand side, if a component didn't come through, it would show up unbold. And so you have capabilities, okay, saying this didn't recognize this, and so I can extract it as a connector or a grommet shown in the demo. And then once that's extracted, then you'll have that information in. And that won't, once you have that profile or config file updated with all your components, naturally that won't happen. But those are different things that you can do within the tool to make sure that those match.
All right, thanks, Cody. We still have a few more coming in. I think we have time for about 2 or 3 more. This one comes from Alexander, and the question is, do you still need to use E3 routing bridge for the MCAD tool to import the E3 schematic design to start the harness?
Let's see, do you still need to use it? No, you can start to sorry, I had to reread your question, but you can start to design in MCAD. A lot of customers do, and you can bring that information in and you can go into a form board. That either way works. And I think that's going to play a lot into what we talked about earlier, is not needing that electrified harness for certain MCAD tools to be able to go through the E3 transformer and ultimately get to the flattened 2D print. I hope that answers your question.
Okay, we have one from Joaquin, and he's asking, can we add tapes or sleeves in the 2D if we do not have this data in the 3D?
For sure, yeah. I mean, you can use E3 series capabilities of adding those into your form board and schematic design. As once you have a form board from what data you do have in the MCAD, you can definitely add that in the E3 series and add those components for sure.
All right, and I think we've got time for just one more, and then we'll call it a day, from Jose, and he's asking, how is the process to merge the wiring from the schematic with the flattened model?
How is the process to merge wiring? I've got to reread that question. So I think what you're talking about is, so I think this is kind of an E3 series functionality. So when you have that schematic information, and as we all know, E3 series is a kind of a multi-view tool. So any information that it's kind of another view, the form board's another view of that schematic. So all that component device information is going to match what you have in your schematic. And so essentially what the E3 3D transformer is bringing over is all the length information and flattening that data. I hope that answers your question. But essentially the process is just the functionality of E3 series. It's going to basically, it's putting another view of what your schematic or you have in your schematics already, and that all that information is linked.
All right, thanks, Cody. Appreciate that. We've got loads more questions here, and if we did not answer your question live this afternoon, we will get back to you and publish those answers so we will make sure that everyone gets their questions answered. So with that, we will conclude today's webinar, and I want to say thank you to Cody and Sima for sharing this great information with us. I hope everyone found it interesting and helpful. And I want to let you know that the on-demand version will be available in the next 24 to 48 hours. If you want to view this again or share it with a colleague, just watch your email and we'll send you a link for that recording. This event is part of Zuken's 2020 Technical Webinar Series, and I would encourage you to visit our library of technical webinars on our website, zuken.com. Our next webinar on the calendar is on May 13th, and the topic is Solving the Systems Engineering, Digital Engineering, and MBSE Puzzle. And I would encourage you to join us for that. As you exit the webinar, please take a moment to let us know how we did. There's a quick exit survey. It's a single question. And again, we'd appreciate your feedback on that. So one last time, thank you again for attending. We appreciate you being here. We appreciate your feedback and your questions. And have a great afternoon.